Hello, I am Neeraj. Today I will try to discuss about Trustable-AI. These days we are using deep learning models in a lot of sensitive areas. So trustability of those models are very important. We can achieve trustability through a lot of different ways, but I am just going to discuss about two important factors. First is how we can reduce the uncertainty to achieve the trustability, how we can improve the reliability to achieve the high trustability of the AI based model built on deep learning systems. So uncertainty based trustable AI again can be divided into two parts: aleatoric and epistemic uncertainties. Aleatoric uncertainty is known as data uncertainties. Epistemic uncertainties are known as model uncertainties. So suppose we are going to develop a classifier, image classifier for all animals. Okay, so we provided all features of cats, all features of dogs, all features of horse, and so on. And based on that, we trained a model. Now, after training, when we try to test this system and pass one image of cat, then the model will predict like that the system is cat with 0.99 probability score and dog with 0.0001, 0.0000, like kind of thing, and similarly it will predict. So based on that, the classifier will say that it is a cat with this probability score. We are assuming that we are perfect, we have developed a perfect system providing the good set of features. So this is the way system is predicting. But now there is a twist in the system. Suppose we take a picture of an apple, fruit, and pass to the system. Then what will happen? System will again say that with low probability score, this may be a cat with 0.29 score, maybe a dog with 0.33 score, maybe a horse with 0.09 score, like that. Means according to this probability distributions, the system will say that apple is a dog with this. So this is a total horrible situation. If the system is predicting like that, this is total horrible situation. Now the best situation can be like the system should give some confidence score. And it says that system is not confident enough to say that this is an animal. So please check or verify or take an additional system or anything that you have, you can use that to re-verify it. This is an ideal situation. So this is called uncertainty of the model. Now the second is reliability. So what is reliability? Suppose you make it to, you have made a tour plan and suddenly you have checked some weather forecast and you find that okay, there will be 55% rain during those days in that places. Then you just change the plan. But after some time you visited there, some other places, and found that for the places for which you have changed the plan, there is no rain. Means the predictions of weather forecasting system is not correct. Means there is a difference between the actual forecasting and the things which are actually happening. So this is called reliability of model. Means model is less reliable because it's saying that there will be a 55% rain with 90% probability, but actually rain is happening, means in 70% cases of time the rain is actually happening. Then model is less reliable based according to its current performance. For that we use the measure of model calibrations and improve the model performance. So this is called reliability. So both are very important to achieve a very high trustable score, very high trustable system. Now we will try to understand in more detail about aleatoric and epistemic uncertainty. Now we have just described that what is uncertainty and what is reliability. So suppose we get one data related to total saving on the purchase of house and total sale of house. So total saving on purchase of house means maybe low interest rate, maybe some discount on a particular kind of sale of home, maybe some government promotion plan, or a lot of things which are actually increasing the total saving on purchase of house, and this is the sale of house. So this is the data we actually get. And when we develop the system based on this data, we find that we are facing the same uncertainty issues with this system. You will say that what kind of and what type of uncertainties we are facing. When we pass the data related to this region, and this region, system is not able to forecast the correct result, predict the correct result, because there is no data in this region. Means, so what we can say that due to lack of underlying data distribution, lack of knowledge of underlying data distributions, model is not performing well. So what is the remedy? So remedy is, we will say that please add some data in this area and then retrain the model, then it will work. So this scenario is known as epistemic uncertainty or model uncertainty. Means model is not working due to lack of knowledge of underlying data distributions. Even after filling the data distributions, we may need some another step to improve the model performance by improving the network architecture of the model. So these two precautionary steps we can take with epistemic uncertainty. Now we will try to understand that what is aleatoric uncertainty. So aleatoric uncertainty is just to check the data in this region. You will find that there are a lot of noisy entries. Noises or randomness in the data. Here you can see that, and due to this, whatever model you will develop, it will suffer and it will not provide the full confidence on the prediction score. So what are the remedies? So first remedy is remove the noisy data from this region, or remove the random data from this region, and then retrain the system. So data uncertainty is just due to inherent randomness on the data. Due to inherent randomness of data. So, first of all, we will concentrate on uncertainty and we will try to understand that if the situation of epistemic uncertainty is there, then how we can identify the reason where data is actually underlying data distributions related information is missing or data is missing. So what kind of data we have to arrange so that the model will perform. And in the case of aleatoric uncertainty, we will try to understand that how we can identify the area where the data is random or some noises are present. So how we can identify and remove those areas so that when we retrain the model, the system will perform and with very high confidence. So these are the two things we will in which we will concentrate. So let us start with uh, aleatoric uncertainty first, and then we will go with epistemic uncertainty.